Okay, so we're going to have a quick lesson on a sequence of two line reflections. Okay, so orientation is going to be a real big factor in these style of problems. Just to let us know, if we only see the pre-image and the final image, we're going to be able to identify if it was one line reflection or two or three or whatnot. Okay, so what we're going to do right now is look at this definition: orientation. What is it? It's the arrangement of three or more non-collinear points. Well, first of all, what does that mean? Why is that necessary? Real quick, let's say we had collinear points. Okay, if those points are all on the same line, we can't determine whether it's clockwise. So when we circle it, we don't know. Is it clockwise or counterclockwise? So that would be clockwise, counterclockwise. We don't know which one it is. So what we have to do is have three non-collinear points. So such as this. Okay. Say we get a figure that's identified as the vertices, MATH, right? So the figure math has an orientation that is, and what we can do is circle the figure. I just put a circle around it. I look for the first point that they identify, point M, and I kind of start right there. Then I move towards the next point they identify and so forth. Okay, that is in a clockwise direction. Orientation, so math has an orientation that is clockwise. Okay, now why is that important in line reflections? Well, when we line reflect, we switch orientation. Okay, so that's the way to identify it. What we'll get in a problem this chapter is a figure like this, right? And if this is the pre-image and this is the image, it's hard to tell without the points identified. It's hard to tell what happened. It could have been a translation based on this. It could have been a rotation of 180. Could have been a line reflection. Could have been anything. Until we identify some points, we're not going to be able to tell. So let's say we go PQRS. Okay. Now, what if that's P prime, Q prime, R prime, and S prime? What if that happened, right? Would we be able to tell now what happened from here to here? And the answer is yes. The first thing we look for is orientation. So identify the order PQRS, okay? That orientation, circle it. Start at P, move to Q, move to R. Okay, that's clockwise. Clockwise. So now if we circle the image and go P prime to Q prime to R prime to S prime, okay, it looks like the orientation is counterclockwise. Now, right away, we know that at least one line reflection was performed. So one line reflection because the orientation was switched. I say at least one because it could have been three, but we'll get into that later. Okay. Now, what would happen if we do a second line reflection? Okay. If each line reflection switches orientation, a second one would switch it back. Now, what we're going to do is we're going to notice, let me write that down. So, a single line reflection switches orientation. The geometry way of saying that is orientation is not preserved. Okay, so you'll hear that or you'll read that. Okay, now a sequence of two line reflections. That means when you do a sequence, you're gonna line reflect over one line, then you're gonna take that new image and then you're gonna reflect that over a second line. So a sequence of two line reflections, orientation will switch back. From the pre-image to the final image. Okay, basically it's going to be, if you have an odd number of line reflections, you'll see it. It'll be switches orientation, and even, we put that in our notes, even number of line reflections, orientation will be preserved. Okay. So we're going to go through some different things and see how that actually plays out, and we're going to use Geometry Sketchpad to demonstrate. Okay, so I set up this Geometry Sketchpad demo, and what I've done is I've created parallel lines. So those are going to be the two lines that we reflect this figure over. So this is going to be our pre-image. Okay. What I'm going to end up doing is for the first line reflection, I'm going to reflect over this line. So we're going to reflect, and we'll label that right there. Okay. Now we're going to take this image, the first image, and we're going to reflect it again. Now remember, the lines were parallel to start, the mirrors. Whoops. Undo that. Never mind. We want to reflect. Okay. Now, what you're going to notice, and what we talked about in class, if you were there, okay, is if we just hide this for a moment, what does it look like from the pre-image to the final image? Well, it looks like, I don't know, it almost looks like we ended up performing a translation. It's equivalent, essentially, to a single translation. Okay, so we'll just check this out. We'll move it around a little bit. It looks like it's still a translation, right? So that's just showing you for different lines that, parallel lines. Yeah, so it's going to look like that. What you're going to notice is if we go close enough, basically you're reflecting over the first line, reflect over the second line, you end up right back where you started. Okay? Now, so that's what we're looking at with a line reflection. A double line reflection, I'm sorry. So let me just go over, we'll jot that down, show what happened. It is going to be a translation. Then we're going to get more specifics as to exactly what is the translation. We'll show you some more stuff here. Okay, so what I did was I clipped that real quick, and I showed, if you look for a second here, after we reflect over two lines that are parallel, right, a sequence of two line reflections where the lines we reflect over are parallel, is equivalent to a single translation. Now I want to get more specific because a translation should have a direction and a distance, and that would give us, kind of a directed segment. So we can be more specific, and we should be. So let's go back over to Geometry Sketchpad and check that out. Okay, so back over here real quick. What I wanted to show was the kind of the directed segment that the translation is defined by, that this actually, happens. So what we do is we consider the distance these two parallel lines are apart. Okay. Now, if you look, what I did was I constructed a perpendicular segment. Okay. So this segment's perpendicular to both of the mirrors. All right. Now, if you can, for a minute, look at that, it should appear that that's also going to be perpendicular. And it is. Okay. If you, let's say we just reflected point A. Watch, it should be perpendicular to the first mirror, right? Okay. So, let me see. Yeah, let's just reflect this. That's right. Let's just reflect that. It's going to land right there. Okay? So that should be A to A prime. Should be perpendicular to this line. And then A prime to A double prime, of course, should be perpendicular to that one. Okay? So that path from A to A double prime is perpendicular to both mirrors. So that would give us our direction, perpendicular to the parallel mirrors. The distance is going to be interesting, though. Okay, I'm going to clip this and go back over to the other to show you a couple different possibilities. All right, so let's summarize this again. Okay, so a double line reflection over parallel lines. I'm just shortcutting this a little bit, over parallel mirrors is equivalent to a translation whose direction is perpendicular to the mirrors and now let's work on the length. Now, let's say for a minute that the distance between our two lines is 10. Okay? Now, if you look, let's just estimate this distance from here to here. Okay? All right, let's say that that's 7. Just for a minute, we can look at it, and we'll say it's maybe 7 or 8. Let's just call it 7 for now. Then from here to here must be 7 as well. Well, what does that leave from A prime to the mirror? Well, if that's all together 10, then that's going to be 3. And if that's 3, then this is 3. So if the distance between the mirrors is 10, it's going to be the distance between A and A double prime is going to be 20. So it's basically what you see is it's going to be double the distance. All right. So maybe that's not convincing. We'll try that again. Let's get rid of this. Let's get rid of these numbers. Okay. Let's say instead it was 8. 8 from here to here. Right? Then from here to here would be 8. And now, wait a minute, what's left? Oh, if it's 8 to there, it must be 2 for the rest of it, because 8 plus 2 is 10. So then if it's 2 from here to here, then it's got to be 2 there. If you add those together, 16 and 4 is still 20. Okay? So it is going to be double the distance between the mirrors. And double the distance between the mirrors. Okay? So that summarizes parallel, double line reflections when they're parallel. We're going to have to look at next what happens if the lines are not parallel. Okay, so we'll go over to Geometry Sketchpad and show you that. All right, actually, well, this is going to be too long of a video, so I'll stop this one here and I'll do the next one on another video. Thanks so much.